So welcome to another video. So this is the video of the discussion or lecture for EDA. Now we're currently looking at the Facebook group now. So okay, so I already uploaded a snippet of the first tweet. So the first tweet is yeah. So this is the first tweet. So we're going to dig into the role of statistics in engineering. What? Nagre-record ako. Okay, so now under week 1, we're going to dig into the topic of what is the role of statistics in engineering. Sige, ito naman ang kulit ni Kenrid, oh. Kulit ni Engineer Kenrid. Okay, fine. So for the overview, we're going to know what are the methods of engineers using to collect engineering data. Also here, we're going to have an overview about the basic principles, again, retrospective study, observational, design experiments, blah blah blah. Okay, so at the end of this chapter, you should be able to do the following. So, identify the role of statistics play, how variability. So, mamaya may encounter natin kung anong ibig sabihin ng variability. Alright? So, mamaya, also, we're going to discuss different methods that engineers use to collect data. And also identify the advantages that design experiments have in comparison to other methods of collecting engineering data. So, explain differences between mechanistic models and empirical models. So, leave out muna natin ang number 7 objectives. Alright? So, as the role of statistics in engineers, well, basically an engineer is someone who solves problems of interest. Okay. So, an engineer is someone who solves problems of interest to society by efficient application of scientific principles. Alright? So, hindi to yung voodoo na tipong hula-hula method lang. So, we use scientific principles. So, kapag sinabi natin scientific principles, alright? Kapag sinabi natin scientific principles, and I may kasama computation, back by science. Okay, kaya nga scientific principles ang tawag. Ito parang nipis. Okay. Alright. Okay, ako malaking eraser. So, engineers accomplish this by either refining an existing product or process by designing a new product or process that meets customer needs. So, kung naalala niyo yung video ko kahapon, engineers are are those professionals that create systems which are efficient, working. Yeah, so naalala niyo yan. So, again, engineers can either optimize. When we say optimize, it's either maximize. It's either we maximize something or we minimize. We minimize something. So it's either we maximize or we minimize something. Again, maximize could be we're going to maximize the profit or maximize the growth, or minimize if we're going to talk about minimize the cost or minimize the amount of materials that we use in order for us to get more profit. So, ganun yan. So, the engineering or scientific method is the approach to solving these problems. So, the steps in the engineering method are as follows. So, saan yung picture dito? Okay. Hindi nasama yung picture. So, engineering methods are the following. So, one is to develop a clear and concise description of the problem. Number 1 talaga na importante dyan is, ano ba yung problema? So, kasi pag hindi mo alam yung problema, hindi mo alam yung mga aalamin mo. Hindi mo alam yung mga data na kukunin mo. Kasi hindi mo alam kung ano talaga yung problema. At again, kapag hindi mo alam yung problema, hindi mo alam kung ano yung tamang solusyon. So number 2 is identify at least tentatively the important factors that affect this problem or that may play role in this situation, in the solution. So, aalamin natin kung ano yung mga factors. So, ano yung ibig sabihin yan? Okay, let me give you an example. Okay, so for example, meron tayong hanap na tayo nito. Motor cycle. Alright. For example, meron tayong ito na lang. Stick ka. Ito na lang. For example, meron tayong motorcycle. Kahit nakikita niyo yung motorcycle dito. So, alright, so may motorcycle na no? So, let's say motorcycle. Okay, let's say motorcycle. So, isa motorcycle yan. So, sabi dito, identify at least tentatively the important factors that affects this problem or may role in this solution. For example, ang problem natin is yung motorcycle natin is mabagal. Okay? So, problem natin is mabagal yung motorcycle natin. So, kapag mabagal yung motorcycle, marami tayong iisipin, di ba? Una sa lahat, baka flat ang gulong. Okay? So, pwedeng mabagal ang motorcycle kasi number 2, sira ang engine. Okay? So, it could also be number 3. Ano pa ba mga usually causes kung bakit mabagal ang motorcycle, no? Or masyadong mabigat. Mabigat ang sakay. Okay? So, papansin nyo na meron tayo at least 3 tentatively na factors na ka-apekto dito sa motorcycle natin. Kaya nangyayari ang problem which is mabagal yung motor. Okay, so yun number 2. So number 3 is propose a model for the problem. So yun ang ginawa ko kanina, no? So using scientific or engineering knowledge of the phenomenon being studied, state any limitations or assumptions of the model. So propose a model of the problem. So this one can already be said as ano nga yung kanina? Already be said as a model of the problem. Kasi na-draw ko na yung schematic. So, problem is mabagal yung motorcycle. So, kapag flat ang gulong, syempre marami kayo kukonsider dyan. Baka, marami pa yun, diba? Baka luma na yung gulong. Pwedeng sabihin natin na kulang hangin. Pwede natin sabihin na, ano pa ba? Okay, so pwede natin sabihin na yun, gas-gas na yung gulong. So kapag sira naman engine, marami ding factor dyan, di ba? So pwede natin sabihin na yung change oil, pwede sabihin na yung gas, pangit yung gas, o pwede sabihin na luma, pwede sabihin na luma na yung engine. So kapag mabigat naman ang sakay, marami tayong pwedeng isipin niya, no? Ano ba yung kilo? Yung weight ng sumasakay or ilan yung number ng passenger. Okay? So nagets nyo naman siguro. So that's number 3. So number 4 is conduct appropriate experiments and collect data to test or validate the tentative model or conclusions made in step 2 and 3. Now, engineers would be so inclined to check or to measure the following. So, number 1, flat ang gulong. Kung flat ang gulong, okay, for example, pag flat ang gulong, for example, kapag flat ang gulong, siyempre, i-measure mo yung pressure gauge, which is, wait lang. Mag-draw. Okay. So, for example, kapag flat ang gulong, siyempre, check natin yung pressure gauge. So, pressure. Huwag ko ba nakahawakan kasi ito? So, pressure gauge, which is in PSI. Alright. So, ano pa ba? Siguro, check natin yung kapal or yung thickness ng gulong. So, na ganon. So, kapag motorcycle naman, kapag change oil, marami tayong i-check dyan na parameter. Pwede natin i-check yung lumalabas dun sa exhaust. Alright? So, sa exhaust na yan, pwede natin i-check yan using yung sa air test. Okay? Yung i-measure yung yung lumalabas na buga ng tambutso. Alright? Kung sa gas naman, i-measure natin kung ilan yung octane ng gasolina. Kasi alam natin, maraming dalawang klase ng gasolina, yung red at yung green na gasolina. At magkakaiba sila ng octane level. So mabibigat naman ng sakay, siyempre, gamit tayo ng weighing scale para masukat ang timbang ng sakay. Alright, so ganun yun. Okay. So, sa number 5 naman, so, refine the model on the basis of the observed data. So, refine the model. This is a very tricky one because, again, maraming factors ang nakaka-apekto kung bakit mabagal yung motorcycle natin. At marami tayong nasulat, di ba, na mga factors na pwedeng nakaka-apekto dun sa motorcycle kung bakit siya mabagal. So, from this data, i-rearrange natin siya in a way na yun, i-rearrange natin yung model on the basis of the observed data. Actually, arrange na rin naman to. Arrange na rin naman ito. Okay, so number 6 is manipulate the model to assist in developing solution to the problem. So medyo complex na to kasi masyadong malaki yung problem natin. Wala tayong nakukuha ang data kasi dito. So, hindi pa tayo makakapag-draw ng conclusion. Okay, so number 7 is conduct an appropriate experiment to confirm that the proposed solution to the problem is both effective and efficient. Now, so, for example, based sa data na nag-gather natin dito, nalaman natin na siguro based sa data na nakuha natin sa ating measurements, nalaman natin na yung pressure gauge ng gulong is mababa. So, since mababa yung pressure gauge natin, syempre, tataasan natin yung pressure gauge at lalagyan natin ng hangin. So sa number 7, ang ibig sabihin yan, kapag nahalagyan na natin ng hangin, yung gulong, itetest na natin kung bumilis yung sasakyan. At kapag bumilis yung sasakyan, edi confirm. Yun yun. So, draw conclusions to make recommendations based on the problem solution. Now, ibig sabihin yan is, so gagawa ka ng report. For example, the observed problem is that the motorcycle is mabagal. And since mabagal, you conducted appropriate diagnosis, and you found out using measurements that yung gulong is flat. Okay, so mababa yung pressure ng hangin sa gulong. Kaya nung dinagdagan mo yung hangin sa gulong, is-test mo siya ulit at biglang bumilis yung motor. Naging mas mabilis na siya. So yun yung sinasabi sa number 8. So yun yung conclusions mo. So these are the steps in engineering method. So this is how we, as engineers, try to find okay, so dito ko lang ha. So first we always start with the problem, and from the problem we probe, and then from the probe we draw conclusions, Okay, so before that, we probe, we test. Okay, and then we test, we draw conclusion. So, ganun yun. So, we always start with the problem and we always end with a conclusion. Okay po? So, that is how engineers should do an engineering, should do the engineering method. Now, so that is how engineers know how to efficiently plan experiments, collect data, analyze and interpret data, and understand how the observed data are related to the model they have proposed for the problem under study. So ganito po. So actually ganyan po. Ganyan ang pagda-diagnose. So papansin, i-analyze ko lang, i-breakdown ko lang para sa inyo. Okay. So, first we start with the problem, no? The problem, and then we diagnose, we list down what could be the factors that affects the problem, which is mabagal. And from those we further analyze and we gather data based on the following. And then from those data that we gathered, kasi makukuha natin dyan. So, from data that na-gather natin, we can draw conclusions. Draw conclusions, and then, yeah. So, yun na yun. So, that is addressing the problem. Eraser. Okay, so yun po ang madaming sulat. Okay, wait lang po. Okay, sabi maraming bura. Okay, select. Alright, go. Okay. So, going to the statistics, going to statistics. So, wait lang. So, the field of statistics deal with the collection. So, engineers, wait lang. Oh, bakit nandito ka? Okay, so yun yung kanina, engineers naman yan. Okay, so engineers. Now, focus naman tayo sa statistics. Right? So, ano yung statistics na yan, no? So, based dito sa book, so statistics deal with the collection, presentation, analysis, and use of data to make decisions, solve problems, and design products and processes. Now, naalala nyo kanina no, nag-gather tayo ng data. So, yung mga nag-gather natin na data, gagamitan natin ng statistics in order for us to draw conclusions. So, the engineers who rely heavily on statistics are sometimes the industrial engineers. Kasi, industrial engineers or IEs are the ones who are designing products, which are ang mga IE kasi kasama sa kanila yung tinatawag na Ergonomics. Okay? Ergonomics. So, ergonomics kasi is, they're dealing with how products or objects affects human experience. For example, itong cellphone. So, ano yung feeling kapag ginawakan mo siya? Yung edges niya dapat curve. So, bakit kaya curve yung edges? Bakit kaya hindi siya sharp? Mga ganun. So, ergonomics yon. So, gano'n siya kagaan, gano'n siya kabigat. So, yung feeling or yung experience ng tao na gumagamit ng phone, yun yung ergonomics. And IE are the ones who are experts in ergonomics. So, kaya lagi silang gumagamit ng statistics because of that primary reason. Alright? Graman natin yan. Hindi naman natin sila kailangan pag-usapan dito. So, now, because many aspects of engineering practice involve working with data, obviously, some knowledge of statistics is important to an engineer, which is kanina, dun sa motor. Specifically, statistical techniques can be a powerful aid in designing new products and systems, improve existing designs, designing, developing, and improving production processes. So for us, engineers, civil engineers or electrical engineers, we can use statistical techniques to design new products and systems. We can also use statistics to improve existing designs and design and develop, not production processes, but we can use statistics to improve machines. Okay? So, statistical methods are also used to help us describe and understand variability. Now, this is the term na medyo common sa statistics. By means of variability, we mean that successive observation of a system or phenomenon do not produce exactly the same result. Alright, so, example. Alright, pakita ko kayo ng variability. So, what I have here is infrared thermometer na lalagyan ko ng battery ngayon. Alright. Papansin nyo, gumagana. Alright, so itetest ko yung kamay ko. So, ngayon, 33 siya. So, kapag nilagay ko yung kamay ko, pansin nyo, 32.6. I-check ulit. 32.5 na. Now, ngayon, 32.1. Ngayon, 31.9. Now, 32.2. So, napapansin nyo, di ba? Even if I'm using the very same instrument or device, and I'm using the same hand, nagkakaroon ako ng variation sa mga nami-measure ko na temperature. Because that's how variability works. That's how it's variability. So, very common yung variability. Now, the question is, di ba ang dami kong binigay na data sa inyo kanina? Ang daming temperature measures na binigay ko. Ano yung gagamitin natin? So, yun yung tanong na masasagot natin as we go on to the topics. Now, continue. By variability, we mean that successive observation of a system or phenomenon does not produce exactly the same result. So, gaya nung kanina. So, as we encounter all variability in everyday lives, and statistical thinking can give us a useful way to incorporate this variability in our decision-making processes. Now, ang variability kasi is common na yan, or natural na yan sa mundo. Natural na talaga ang variability sa mundo. And since normal na ang variability, how do we deal with variability? Alright? So, how we deal with variability in our decision making? Ayan. Okay? So, kanina nagbigay ako ng example na to, no? Mas maganda pa to kaysa dito sa example dito. Okay? So, continue na lang natin. So, here, we start here. So, often, physical laws such as Ohm's law and ideal gas law are applied to help design products and processes. Kasi may formula na tayo. But we are familiar with reason from general laws to specific cases. But it's also important to reason from a specific set of measurements to more general cases to answer the previous questions. And this reasoning is from a sample which is yung kanina, to a population. So, the reasoning is inferred as statistical inference. So, ano ba ibig sabihin nito? Ibig sabihin ng statistical inference is that you get a conclusion or you get an information regardless of the variability if you use statistics. Alright? So, for example, ito For example, meron tayong itong nasa picture na to, no? Yan. So, ibig sabihin yan. So, this is target population and sample. So, target population is yung population mo. For example, Filipinos, no? For example, ito yung mga Pilipino. Okay? So, where 1 human is equivalent to 1 million. Okay? So, ibig sabihin, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wala niya, 10 yan, times 1 million. So, ganun kadami yung population natin. Alright? So, from this population, only a selected few yung kukunin natin. At which is 1, 2, 3, 4. So, gumamit lang tayo ng 4 times person as our sample. Now, yung mga sample na yan yung ating pag-e-experimentuhan. Alright? So, yung 4 na samples na yan yung pag-e-experimentuhan natin in a way na magkukulit tayo ng data. Right? So, clearly, reasoning based on measurements from some objects to measurements of all objects can result in errors or sampling errors. So, sabi dito, reasoning based on measurements from some objects to measurement on all objects can result in errors called sampling errors. So, what does it mean? So, sampling errors is like this. So, di ba? Napapansin niyo, yellow yung ano niya, yung shirt niya, yellow. Di ba hindi naman yellow ang lahat ng t-shirt ng tao dyan? At hindi rin lahat, napapansin niyo, red. Hindi naman lahat yan ay red. At white, at black. Okay? Napapansin niyo, no? Meron tayong hindi nakuha dyan, which is blue. Wala tayong nakuha blue at green. So, yun ang ibig sabihin dyan. So, hindi kasi lahat ng tao pare-pareho, no? So, maraming klase ng tao. Maraming klase ng tao. So, kapag pipili tayo ng sample na ganito, very limited to only 4 population, hindi natin na-consider yung blue, hindi natin na-consider yung green. So, dun tayo papasok sa error na tinatawag na sampling errors. Alright? However, sabi dito, if the sample is selected properly, this risk can be quantified and an appropriate sample size can be determined. Because again, looking back at our example, sa dami ng tao na yan, kaya pipili mo, ibig sabihin lang kasi niya, yung sample na yan, na-select lang yan in random. So, ibig sabihin, random selection ang nangyari. So, random lang. So, sa population na yan. So, sa random na yan, hindi, obvious naman na meron talagang iba dyan na special na hindi natin nakukuha. At yun ang ina-expect natin sa sampling error. So, ibig sabihin, para ma-overcome natin ang sampling error, delete ko lang ito. So, para ma-overcome natin yung tinatawag na sampling error, obvious naman, pipili tayo ng mas malaking population or sample size. So, sample. So, gagamit tayo mas malaking sample para mabawasan natin yung tinatawag na sampling error kasi mas marami tayong na-test. Yun ang ibig sabihin nun. Alright? So, in the production of goods, it is important that less or no defects are found. For example, meron tayong ginawang 100 na smartphone. Okay, example natin yung mga smartphone, no? For example, isang box yan. Yan yung box ng smartphone. Where one box is equivalent to 100 iPhone na lang. Okay? So, at meron tayo na-produce na 1, 2, 3, 4, 5 box ng box ng phones which yung isang box is 100. Tapos, let's say no, pumili tayo ng in random ng isang box. Okay, pumili tayo ng randomly isang box, ha. Hindi ko sinabi kung ano yung number, bigla lang ako kumuha. Tapos binuksan natin yan. Okay? Binuksan natin yung isang box na yan. Tapos, di ba 100 yan? So, sa 100 iPhone, let's say, kumuha tayo ng 10 piraso. Kumuha tayo ng 10 phones. Tapos, sa 10 phones na yan, meron tayong na-test at merong nakuwang 3 defect. Okay? So, ibig sabihin, 3 out of 10, or let's say, 30% is defect. So, napakalaking percentage yan kung tutuusin. Kasi, ibig sabihin, there are at least 30% in the manufactured which are defect. Could be, possibly. So, ibig sabihin, if we have 5 boxes, times 100, ibig sabihin, 500 phones. Imagine nyo na lang kapag times 30% yan. So, ilan yan? Bobo ko sa math. Calculate ko lang. 500 times 0.3. O, imagine mo, meron na agad 150. May 9%. Ibig sabihin na agad mamaya na nag-record pa ako. Mamaya na. So, excuse me. So, ibig sabihin, meron tayong 150 na defect. No? Isipin natin ganun. So, imagine nyo lang 150, no? Tapos papunta sa iyo isang telepo na sira. Tapos binayaran mo yan ng 20,000. So, ang saklap, diba? So, as much as possible, no, dapat wala tayong defect or less yung defects na ating production. So, in statistics, stability is the term used to describe the result that is not changing or is the result of dependable. So, ano ibig sabihin yan? Now, let me elaborate. Okay, so balik tayo dito sa ating boxes. Okay, so let's say yan ay batch 1. Nabalik ko lang. Let's say what this is batch 1. So, B1. Tapos, nag-manufacture tayo. Batch number 2. Same lang din. 1, 2, 3, 4, 5 boxes na. 1, 2, 3, 4, 5. Pero ibang box. Pero magkaiba naman. Now, on this time, instead of choosing box number 3, we choose box number 1. So, kapag nag-arrive pa rin tayo sa same na 3 defects per 10 iPhones na nakuha natin sa ating sample, which is 30%. So, ibig sabihin, talagang malala. Ibig sabihin nun, meron ng problem sa mismong machines or mismong manufacturing processes ng phone. Kasi consistent, or let's say na hindi 3, no? Sabihin natin na 2 out of 10. So, ibig sabihin, 20%. So, malaki pa rin. So, ibig sabihin lang nun, merong problema sa planta. Okay? Okay? So, elaborate ko lang lalo, no? Since nalaman natin na, meron palang problem sa planta. May problem sa ating manufacturing. Now, sa manufacturing natin, as an engineer, marami tayong iisipin dyan kasi maraming factors na nakaka-affect sa manufacturing. Let's say, maraming components sa manufacturing, no? Let's say, merong limang components sa manufacturing. So, iisa-isahin natin ang errors. May makita tayong problem dyan sa 5. Okay? So, ganun ang pag-troubleshoot. So, an enumerative study, the sample is used to make an inference to the population from which the sample is selected. In an analytical study, the sample is used to make an inference to a conceptual future population. So, the statistical analysis are usually the same in both cases, but an analytic study clearly requires an assumption of stability. Now, balikan natin to. So, dito, an enumerative study, the sample is used to make an inference to the population from which the sample is selected. Kung naalala nyo kanina, yung population dito sa taas, ito, population ito sa taas, ito, yan. Pwede natin sabihin na yan ay enumerative study. Okay? But in analytic study, the sample is used to make an inference to the conceptual future population. So, ibig sabihin lang yan, kapag analytic study ang ginawa mo, okay, balikan natin yung tao kanina. Kapag analytic study ang ginawa natin dito, alright, ibig sabihin lang nun, analytic study means that kung ano man ang results ng ating findings dito, pwede natin sa, for example, this is the year 2019. So, year 2019 study, nalaman natin na 1 out of 3 is diagnosed engineer. Okay? So, kapag analytic study yan, by the year 2020, ganun pa rin yung iisipin natin. So, that's analytic study. Alright? So, that's the end of this video.